Good morning, students. Today we will start new chapter, limits and derivatives, chapter number 13. We will start chapter number 13, limits and derivatives. First word, limits. We will discuss what is the limit and how to calculate the limit of the given function. Here some illustrations are given in the NCERT. We'll start from the illustration number 3. Consider the function f(x) is equal to 3x. Let us try to find the limit of this function x is equal to 2. The following table is given to you. Now here limit word is used. We will discuss what is limit. Now here, suppose the question is given here, that is f(x) is equal to 3x. And I have just put the value of x is equal to 1.9, 1.95, 1.99, 1.999, 2.001, 2.01, 2.1. Now you can observe from here on the number line, here is this 2, where you want to calculate the limit. When you tend towards 2 from the right hand side, very near to 2, the value is 2.01, 2.001 and so on. And if you tend towards 2 from left, the value is 1.999, 1.95, 1.9. It means up to this is the left values. Sorry, this is up to this left values. And from here, all the values are from right hand values, and these are left hand values. Now you can observe when you put 1.999 in the function 3x, you are getting the value 5.997. If you put the value 2.001 in the function, you will get the value 6.003. Now you observe here, these two values are very near to 6. 5.99 can be written as 6 and 6.003 is also tending towards 6. It means when you are putting the value very near to 2 from right hand side or from the left hand side, you are getting the value tending towards the same value number. Here that number is 6. This is the meaning to what is the tending towards from left and right. If left and right both are tending towards the same number, then the limit exists, otherwise limit does not exist. Here from this table you can see here that the values from left and from right both are equal to 6. When you write tending towards 2 from left, it means 2 minus like this. This will give you idea of left hand limit. And when 2 positive, it means right hand limit. So both values are same. That value is 6. So what the function is, the limit is existing on the given function. Here a lot of examples or illustrations are given to understand the idea of the limit. Let's see other example. Here in this example, consider the constant function f(x) is equal to 3. Let us try to find its limit at x is equal to 2. Now you can see here is a number line, 2 is here. When I tending towards from left hand side, here is 1.9 value, suppose. From right hand side, suppose it is 2.1. When you want to put these values in the given function, here x is not lying, only f(x) is equal to 3 is there. If x is not there, it means you can't put the value 1.9 or 2.1. The value will always be 3 because x is not there, you can't put the value of x. So function is giving the same value from left and right, so limit exists. Here you can see the solution. Both values from left and right, both values equal to 3. So what? The limit exists. Now example number 5. Here the function is given. Function is f(x) is equal to x square plus x. And you have to check at x is equal to 1 whether limit exists or does not exist. When you are talking about x is equal to 1, it means from left or from right, you have to put the value in the function. Up to this is the left of the left hand values, and these are the right hand values. You can see very near to 2, very near to 2 from right and from left. The value is 1.99 and here is 2.03. Both are tending towards 2. Tending towards means not equal to 2 but very near to 2. Very near to 2. Both values are equal to 2, or you can say tending towards 2. Here it is written equal to 2. It means that when you tend towards 1 from left or from right, you are getting the value tending towards the 2. So what the given function is showing the limit exists. Graphs are also given in the function. You can study these graphs. In all the illustrations, it is given to you from left hand side and right hand side, values are given to you, and you have to just check you're getting the same approach. Here are a few examples where you are not getting same value. Let's see. Here is a graph which will give you an idea of this. Now you can see here when you are tending in the function, here you can see, I think I have to give the question statement also. Yes. Fx is equal to x minus 2 when x is less than 0. At 0 it is 0 and greater than 0 you are getting x plus 2. It means what? Here is a 0. When you are tending towards the 0 from right hand side, then you have to put the value in the function y is equal to x plus 2. So the value of y will be equal to here 2. Because when you put x is equal to 0, you are getting 2. When you are tending towards this 0 from left, then you have to put the value in this x minus 2. The value will be y will be equal to minus 2. It means what? Both are giving different values. If when you are tending towards left or right, the y's are different, so limit does not exist. Now next, here you can see the graph. In illustration 10, when limit tending towards 1, when from left or right, you will put the value in x plus 2. At x is equal to 1, it is 0. But when it is tending towards 1 from left and 1 from right, then it is the value you have to put here in the function x plus 2. We are getting 3. It means what? Very near to 3 approaching the value. This is from left and this is from right. Both are approaching towards 3. Limit exists. Fx is equal to 3. Here I have to told you. Here is it also 3. This is 3. Now here we can see. Notice that at given point the value of function, its limit may be different even when both are defined. Limit may be different. X is equal to 1, limit from left and right both equal to 3. And from right, concise, hence the graph is as given. That is okay. Now you can see the graph and analyze the question. Now how to use this limit under this algebra? Here are the few theorems. if you are applying limit on two functions which are added, you can separate the limit on first and second. In difference also, you can separate the functions. And in product also, you can separate the limits on the functions. And in quotient form, if the function is written, then you have to remember that denominator should not be equal to 0. It means denominator function should not be 0. This gx should not be equal to 0. Here is written this one. And limit on the polynomial functions. How to apply the limit on the polynomial function? It means if the polynomial is given to you, you have to apply the limit to each and every term of the polynomial like this, and simplify all the terms separately and add them, and you will get the answer. Now here are few examples. Illustrations give you idea about the concept. What are the left hand limit and right hand limit, and what is a limit? Now examples will give you an idea how to solve the questions of the limit. Now first example, before we start to solve the examples, I was just giving to you an idea about it. Here are a few steps you have to remember. First step, first you have to put the value which is given tending towards x tending towards 1, or limit is given to you. Put the value of the limit in the given function. If it is solved, it means what? The answer you will get. But if it is not solved, you are getting 0 upon 0 form. It means numerator becomes 0, denominator becomes 0. Then eliminate this 0 upon 0 form. How you can eliminate? First thing you can do, first you have to, if there are the quadratic equation or any equation, cubic equations are given to you, you have to factorize the numerator and denominator equations and struck off the common part. Or you can say the simplify the function by factorization. Second thing, you can, maybe square root sign is there in the question. Rationalization can be used to simplify the question. Third one, substitution method you can apply to eliminate the 0 upon 0 form. When you able to eliminate the 0 upon 0 form, it means you can do the question easily. Now here in the example first, here the first question, it is written limit x tending towards 1 to the function x cube minus x square plus 1. Now you have to put the value 1 here in the question. When you put the value 1 at the place of x, put 1 and simplify, you are getting 1. In the second question also, put x is equal to 3 in the given function, you are getting 12. And put x is equal to minus 1 in the third part, and you will get the answer, that is after simplification equal to 1. In all these parts, that after substitution the direct limit, you are getting the answer. In the example number 2, first part, when you put x is equal to 1 in the function, you are getting what? X is equal to 1 means 1 plus 1 upon 1 plus 100, that is 2 upon 101. You can see here in the question, 2 upon 101 directly. In the second part, when you put the limit, you are getting 0 upon 0. What is the meaning of this? It means you are getting 0 upon 0 form. You have to eliminate this 0 upon 0 form after simplifying the question. How to simplify the question? Here quadratic and cubic are given to you. You have to solve by taking common. You can take common x from the statement. This is x plus 2 and x minus 2. And upper one is x minus 2 whole square. Cancel the common factors. You are getting this statement and put the value x is equal to, and you are getting 0 upon 4. Now this is not 0 upon 0, this is 0 upon 4, and any number divided, 0 is divided by any number, you are getting 0. This is the answer. Now in the third part also, when you put x is equal to 2 in the question, given function, you are getting 0 upon 0 form. Now for further simplification will be done, x plus 2x minus 2, and same question is given but numerator and denominator are interchanged here. So now question becomes same part, cancel the common part, you are getting 4 upon 0. Previous one you have got 0 upon 4, here is 4 upon 0. Any number divided by 0 means infinite. It means you will write down which is not defined. You can't divide by 0. In the fourth part also, when you put limit, you are getting 0 upon 0 form. Simplify it. Here we have simplified. Common factor cancelled. And again put the value x is equal to, you are getting minus 4. This is the answer. Same fifth part. 0 upon 0 form can be eliminated by taking LCM. LCM is taken and simplify it. After simplifying, quadratic is there in the numerator. Factorize the numerator and you're getting x minus 3, x minus 1. Common factor is cancelled. Our target is to cancel the common factor. If common factor is cancelled, then you can put again the value of x is equal to 1 or limit which is given to you, and you will get the any number. Here you will get the number 2. This is the answer. Now here is the next theorem which we will use when the limit x tending towards to a to the function x to the power n minus a to the power n upon x minus a, then you will write directly equal to n into a to the power n minus 1. This is a formula which you have to remember. Derivation is there in the question. You can try that derivation, you can do the derivation. Here we will apply the same formula. X to the power 15 minus 1 upon x to the power 10 minus 1. Now question is x to the power n minus a to the power n upon x minus limit x tends to a. Now this question can be converted into this form by dividing by x minus 1 to the numerator and denominator both. Like this. Now this question becomes in the form this one. Because limit tending towards to 1, here is 1. Because a tending towards to a should be there. Now you have to write down n a to the power n minus 1, direct answer. What is the n? N is 15. A is 1. 15 minus 1 is 14. And same is here, 10 into 1 to the power 9. Simplified, 3 by 2 is the answer. Now next question. Here I can do this question in a different way also. I will do by rationalization. You can do this by this substitution method. I have told you next method, that is the rationalization method. I can rationalize the numerator here like this. Now a plus b a minus b in the numerator. Like this becomes limit 1 plus x minus 1. This x under root of 1 plus x plus 1. These are to cancelled. Limit x tends to 0, x upon x under the root 1 plus x plus 1, x cancelled. Put x is equal to 0, you are getting 1 upon root 1 plus 1, that is 1 upon 2. This is the answer. You can do by this method also. This is the method, substitution method given in the question. By substituting y is equal to 1 plus x. If y is tending towards to 1, here when you are substituting the function, limit will be changed according to the given substitution. If y is 1, then x is tending towards to what? 0. If y is 1, x1 are cancelled, x tending towards to 0. So limit will be changed. Here x tending towards to 0. Now apply the formula which we have just studied, x to the power n minus a to the power n upon x minus a, and limit tending towards to a. Same formula is applied here, and you can do the question. Answer will be 1 by 2. By rationalization and by substitution, you can do the question. Here are a few more formulae which are related to the trigonometry. Trigonometric formulae, which are, one formula is sine x upon x, limit x tends to 0, you can write that is equal to 1. Here I am writing limit x tending towards 0, sine x upon x, you will write down 1, limit x tends to 0 to the cos x, that is 1, limit x tends to 0, tangent x upon x is equal to 1. These are three formulas which you have to use in the case of trigonometry. Here 1 minus cos x upon x, limit x tends to 0 is given to you. Here whenever you got 0 upon 0 form in trigonometry, you have to apply the trigonometric formula to simplify it or to eliminate the 0 upon 0 form. In the second part, you will use the formula, trigonometric formula. This 1 minus cos x can be written as 2 sine square x by 2. Now this 2 can be shifted to this, or you can write like this, and sine square can be separated into functions, sine x by 2 into sine x by 2, and this becomes a part where limit x tends to 0, it becomes 1. And 1 into sine x by 2, where when you put x is equal to 0, we are getting 0, and 1 into 0 will be equal to 0. Now further, sine 4x upon sine 2x, you can write this sine 4x as 4x dividing by 4x and multiplying by 4x, and this 4x can be written as 2 into 2x. And when you take this part, this is 1, take this part, this is 1, and this is 2. 2 into 1 into 1, answer is 2. And tangent x upon x is, I have told you, it is equal to 1, and you can do it by taking sine x upon cos x, and you can write like this, sine x upon x into cos x. In the second part, yes, here, sine x upon x into 1 upon cos x. It is 1 and it is 1, so 1 into 1 is 1. Now here is exercise 13.1. Try the questions of exercise 13.1. We will discuss in next video the important questions of exercise 13.1. Thank you. Have a nice day.